we're given an angle that is not between two given sides, and that creates an ambiguous situation. There's two possible triangles. So if I sketch an angle 34 degrees right here and say that this is 8 centimeters, my other possible side is 6 centimeters, that can intersect either here or here, depending on whether it swings out and intersects or in and intersects. We can get either a short base here or a long base. So if I draw the two triangles separately, I would have one that sort of looks like this, and the other with this look. And we're trying to find the two possible lengths for AC. So I'm going to go ahead and call that A. Now there's a couple of possible ways to do this. I'm going to start by demonstrating using the law of cosines. Law of cosines is c squared is equal to a squared plus b squared minus 2 times a times b times the cosine of c. Now the important part is that the location of our c. The given angle is 34, so this has to be our c for the equation, and that means 6 is going to be our c variable. So I'm going to fill in the c with 6. A is what we're trying to find. B is 8. Continue to fill this in. Cosine of 34. Okay, now I'm going to clean this up a little bit, do a little rearranging. I know that this is 36. A squared plus 64. I'm going to multiply my 2 with my 8, get minus 16 cosine 34 times A. This is a quadratic, so I'm going to move everything to one side. So I've got a squared minus 16 cosine 34a plus, and when I subtract the 36 from both sides, I end up with 28 here. So quadratic formula time. My a value is 1, my b value is all of that, and my c value is 28. So the opposite of b, that's going to be positive 16 cosine 34 plus or minus square root of 16 cosine 34. Now it's a negative. It doesn't really matter because I'm going to go ahead and square it in a moment. Times 4 times a, which is 1, times c, which is 28. All divided by 2 times a, which is 1, so I'm just going to put 2. Okay, 16 times the cosine of 34 happens to simplify to about 13.3. So I've got 13.3 plus or minus the square root of 13.3 squared minus 4 times 28 divided by 2. This simplifies to 13.3 plus or minus the square root of 63.9 divided by 2. And so we're going to get our two answers, 13.3 plus approximately 8.06 divided by 2, giving us approximately 10.7 centimeters. And the second is the minus 8.06 divided by 2. That we get approximately 2.62 centimeters. And so A is 2.62 for the shorter version of the triangle, the smaller one, and this one is 10.7 centimeters. So that's how that part can be done using the law of cosines. So we found the two possible lengths. What's the difference in the area of the two triangles? To find that, we're going to need to use our side angle side area formula, where our area, which stands, we use K as the variable, it's A times B times sine of C divided by 2. So we can find the area of each by substituting. So one of them is going to be 8 times 2.62 times the sine of 34 divided by 2. And the other one will be 8 times 10.7 times the sine of 34 divided by 2. And after calculating the two of those and finding the difference, it should be approximately 17.89 square centimeters for the difference between the two. That's part C. Okay, now I'm going to do a quick demonstration of finding the two different triangles using the law of sines instead. So let's get some more space here. There we go. Okay. So again, my two possible triangles, 34 degrees, 8 centimeters, 6 centimeters, and the smaller one, 34 degrees, 8 and 6. Using law of sines, I can find my two angles. I'm going to go ahead and find the two possibilities for this angle here. I'll go ahead and call them alpha. So, setting up law of sines, it's the sine of the angle over the opposite side equals sine of the angle, alpha, over the opposite side. We get the same thing for both of these. So 8 sine alpha equals 6 sine Here we go. It's actually 6 sine of alpha times equals 8 sine of 34. And then we can divide both sides by 6. So sine of my angle is going to equal 8 sine 34 divided by 6. And we need to do the inverse sine. So let's pull up a calculator. Where's my view that only shows my calculator? I need to figure out how to do that in a bit. Here, I'll just do it on my calculator over here. So sine of 34 divide by 6. Need to find the inverse sine of that. Okay, and I got 48 degrees, 48.2 degrees. So, which one must this be? 48.2 degrees. Recall that when you do the inverse sine of something, you only get one answer or the other. So this one's my 48.2 degrees. This one is going to be an obtuse match to that. If we take a look at the unit circle, and think about, let's say in this quadrant here, there's a 48-degree angle. So we're saying from here to here is 48 degrees. So my obtuse angle that's a complement to that, or supplement to that, is an angle that is 48.2 degrees away from 180 degrees. So to find the second angle, I need to do 180 minus 48.2 degrees to find my second possibility. So, oops. The obtuse version of the angle would be 131.8 degrees. Then we can continue to solve for the rest of the angle using the law of sines. We can find this missing side and this missing side using law of sines, given that we have all of the angles that go with these triangles. Okay, next time moving on to problem number 166. Thank you.